Summarising data, example 4. This is a bit of an unusual example because what happens here is that we're given a mean of a sample of 25 observations. We're given the answer. We've got a mean of a second sample of observations, a different number of them. That works out to be 7.2. We've got to work out the overall mean. Now, it's tempting just to add together the 6.4 and the 7.2 and half it. That wouldn't be fair because that puts too much weighting on this first one. And in fact, we call it a weighted mean. We've got 25 observations in the first category and 30 in the second. So we have to give sufficient weighting to the second to show that it represents more people or more observations. So the way to tackle one of these is to use the formula for the mean and rearrange it. We know the mean is given by x bar. You will have looked at that in your notes. So x bar is the sum of all the values divided by how many values there are. I'm going to rearrange that formula. I'm going to cross multiply, and I'm going to say that if I do n times the mean, so I'm multiplying by n on both sides, that will tell me the sum of the values. I'm then going to combine the two groups of data together and get an overall mean. So let's have a look. The first sample, there are 25 observations. The mean works out to be 6.4, and if you multiply those together and then look at the second sample, there's 30 of those, and on average they are 7.2 each. Work those out and add them together, and that works out to be 376. In other words, the total sum of all the values, all 55 values, is 376. This gives us the sum of the first set of data. This gives us the sum of the second set of data, and if we add them together, that gives us the sum of all 55 items. Now that we know the sum of all 55 items is 376, we know there's 55 of them, so we can divide by 55, and that works out to be 6.84, which seems reasonable because if you look, the first sample was 6.4, the second sample was 7.2. We would probably expect that the mean of the whole sample will be somewhere in between, which it is. That is called a weighted average. Weighted average or a weighted mean. And that's important in cases where the samples are different sizes. If there'd been 30 in each sample, you could have just added the two means together and halved it because they were both of an equal weighting. But in this case, you can't do that.